Hello internet, what's going on? And once again, welcome back to the most inquisitive channel on YouTube, Life's Biggest Questions. As today, we curiously ask the question, what if our sun was a neutron star? Roll the clip. For the curious amongst you, that clip was from Danny Boyle's sci-fi extravaganza, Sunshine. And yeah, come on guys, this video is about our sun, so we've at least got to build some visual tension and atmospherically set the scene, right? Right. It leads us to an important point though, because there are no visual depictions of a neutron star because, well, they're so weird and so small that all the technology on the planet still couldn't manage to muster a few snapshots of the strange and mysterious solar bodies. But that's okay, because we've got everyone's favorite visual supplement to set the scene, theoretical physics. Right then, so neutron stars, what are they and what's the big deal? Well, in short, neutron stars are the collapsed cores of massive suns, but they have a few very particular parameters that they need to meet before they can call themselves neutron. Our sun, Sol, is pretty middle of the pack when it comes to the weirdness of far-flung celestial bodies, but stars with a much larger mass than our sun burn out after just a few million years in a massive galaxy-rocking explosion known as a supernova. During a supernova, all of the inner cosmic mush of the star in question, millions of tons of plasma and neutrinos, get ejected out from its core at the speed of light. But strangely enough, sometimes there's something left behind, and that little guy is a neutron star. Now, it's important to note that our sun will never become a neutron star because it doesn't meet those very specific set of parameters and conditions needed for it to turn into one. Neutron stars are born from suns that are 10 to 20 times the size of Sol, and in around 5 billion years, the life cycle of our sun will lead it to become a red giant and then eventually a cold white dwarf, which is vaguely similar to a neutron star without the weirdness, just much larger and far less dense. But we don't want that, do we? Because this is a hypothetical life's biggest question, and we want to know what this would mean for our sun and how damn dangerous things would get very, very quickly. What? You didn't expect a happy ending, did you? Well, it's no kept secret that a neutron star is one of the strangest things in our universe. It's right up there with dark energy and white holes, giant flying spaghetti monsters, Cthulhu and all his buddies. Because after spending its life as an absolutely massive star, post-supernova it shrinks down to roughly the size of a small city, around 20 kilometers from head to toe. But you know that stars are spherical, don't you? So don't worry about metaphorical appendages. The thing is though, the fact that these things are absolutely tiny on the scale of the universe, it doesn't account for the fact that a single cubic centimeter of a neutron star weighs roughly 400 million tons. A single cubic centimeter. Now multiply those centimeters by several hundred million and you get, yes, a pretty hefty small boy. In fact, even at that size, thanks to the weirdness of a neutron star's physics, its gravitational force would be roughly 2 billion times stronger than Earth's. That means quicker than a rat up a drain pipe, every single planet in our solar system would be instantly pulled toward the neutron star and destroyed in a hail of cosmic hellfire. Yeah, that's not so good. Also, things wouldn't just end there either, because these little guys rotate at a phenomenal speed outside of our given understanding of galactic orbit. You see, whereas our sun rotates once every 27 days or so, a neutron star would rotate roughly 700 times every second, and it would be hurtling through space at 1/5 the speed of light like a toddler at a Red Bull convention. In fact, if our sun was a neutron star, we'd likely never even know it, as life and everything in the galaxy would swiftly come to an end in the spark of an instant. That's if our sun suddenly morphed into a neutron star, but what if one of those guys came hurtling at us from the deep depths of space without a second thought? Even though a neutron star is roughly only 20 kilometers wide, when compared to our planet, which has a diameter of 13,000 kilometers, you may think that it'd be just like getting hit by an asteroid, but we're also forgetting how heavy these things are. Remember when I said a single cubic centimeter of a neutron star weighed roughly 400 million tons? Well, yeah. If it impacted our Earth, it would be like shooting a bullet through a watermelon. In fact, it's one of the few cosmic entities in the known universe that would literally obliterate our Earth by passing through the core of our planet and exiting out of the other side, 360 no scope and all. Yeah, it's safe to say these guys are pretty deadly, and under any theoretical scenario, things would be really, really bad if our sun ever became a neutron star. But is there any upside to our sun ever being a neutron star? Hypothetically, of course. Well, perhaps, but we'd have to change the mechanics of our solar system for that to even be an option. You see, because despite all of the cosmic calamity that these little guys can cause, it is still often theorized that neutron stars across the universe may have planets in orbit, albeit in a very precarious balance, stuck between a rock and a hard place, so to speak. You see, because neutron stars have such an overwhelming magnetic force, life on such a planet could harness that power similar to how we harness visible light from Sol. Of course, for the most part, a neutron star would emit enough light energy, but the overwhelming radiation from its magnetic force could have completely shaped its course and evolution of any sentient life. An entirely new concept of life could have grown on this hypothetical planet that hangs in the delicate balance of a neutron star's orbit. Sentient life that fed on radiated cosmic energy to become an entirely different life form than that of humanity, using galactic cosmic rays to sustain themselves and perhaps become an even more efficient extraterrestrial life. Heck, if this radiated alien species became an advanced enough civilization, they could even perhaps construct a Dyson sphere, a hypothetical megastructure that completely encompasses the star and efficiently harnesses its energy. There's one thing for certain: whichever way you spin it, a neutron star has more potential energy than any known cosmic entity in our galaxy. If a civilization was lucky enough to grow in the strange, delicate balance of having a neutron star as a sun and survive its cosmic calamity and all the things that come with having one of the most earth-shattering entities in the known universe as a neighbor, then there's also a very good chance that their civilization would be incredibly advanced thanks to the potential technological abundance of a neutron star. Hey, if that's the case, maybe they'll be paying us a visit sometime soon. Oh, I hope they're nice.
What if our sun turned into a strange star? Strange star, strange star, strange star, strange star. So, strange star doesn't mean like kooky cocoa snaps. It means like, well, we'll get into that. Before we start this video for reals though, I want to ask you what year you think humans will leave our solar system to explore another. I'm thinking the year 2175. Hello, future humans watching from 2175. How's it all going? Bon voyage. If you're watching this video, do let me know your thoughts in the comments section down below, and also please do leave a thumbs up on this video and share it with a friend. Do check out the links in the description box for sources and the socials of people who went into making this video. Alright, strange star, what even are you? Listen, this is deep physics. I'm smart, but I'm not Stephen Hawking smart when it comes to observations in space-time. If you're interested in this topic, I would absolutely encourage you to research it for yourself. This video is purely based on my understanding. There are a lot of benefits to our sun being a medium-sized star, but its size determines how it will die. Our sun has a lifespan of roughly 10 billion years, and it is currently 4.5 billion years old. In just over a billion years, it will begin its end of life phase, and it will start to expand. Eventually, when it exhausts its hydrogen core, its helium ash will collapse under its own weight, causing our sun to heat up so much it explodes into a red giant, which means it'll be so big it swallows Venus and Mercury, and if we're not already dead, we certainly will be by then. After that, the sun's mass will convert to carbon and it will shrink to 10 times its current size, but shine 50 times brighter until it burns itself out. This isn't the fate of all stars though. Bigger suns can become neutron stars, and even bigger suns can become black holes. From my understanding, a strange star, often known as a quark star, is somewhere in between a neutron star and a black hole. So, what is it? Mate, honestly, that's a hard one to answer. They still are not legit proven actual factual things. They are hypothetical. But the theory is that they are made up of quark matter, which is a substance that makes up protons and neutrons, so all atoms. And when quark flows together in a mass, it bends the laws of time and space. Quark stars, strange stars, they're very dense. Strange matter may be dense, but it is also stable, which means, in theory, it could exist forever. So, if our sun was a strange star, it may literally last forever, but forever is an unknown concept to us. Everything we know has a lifespan, so this is hard for us to get our heads around, but please let's try. So if our sun were a strange star, it would emit far less light, which would mean days would only be marginally lighter than nighttime. We need solar rays to heat the Earth, and without it, the Earth would dramatically cool. It wouldn't be immediate, but within a year the Earth would be far too cold to inhabit. Humans would have have to try and find a way to generate heated living spaces before things got too cold. But of course, animals would die out, and without sunlight, farming in general would be a key issue. Eventually, the oceans would likely freeze too, with life only surviving at the liquid seabed, kept slightly warmer by its proximity to Earth's molten core. Speaking of, if we wanted to stay warm, our only option would be to basically get in the ground. But would we have the time, tech, and skill to do so? To be honest, there'd be little point. A strange star would be far more dense than our sun, which means it would have a greater gravitational pull upon us. We would be drawn closer in, as with the rest of the planets in our solar system. This could lead to a planetary smash, although, if we're lucky, in a 1 in a strange star trillion chance, perhaps the gravity effect will pull us into a new, closer habitable zone. If we moved far away from where we are now in our current sun's orbit, it would pull us out of the Goldilocks zone. But with a strange star, there would be a new habitable orbit range. If that was the case, then, well, things may not be so bad. But actually, arguably, be pretty great. Why? Well, in theory, it means that we could have lengthened our expiry date. Right now, humans will die when our sun does at the very least, if we don't wipe ourselves out in the first place. But if we were in a habitable orbit of a hypothetical strange star, well, it means that we could call Earth our home forever. Unless, that is, we continue along with the whole pollution, fossil fuel burning, tree cutting, warmongering path that we have found ourselves on in the past. Well then, just forget I said anything. Oh, one more thing about our mate, the strange stars. Like I said, this is super deep space theory, but it is suspected that if two strange stars collide, or even two neutron stars collide, strange matter could be spilled and spewed into the ether. This spewed matter is sometimes referred to as strangelets. These roving strangelets turn everything they touch into strange matter. These particles could be hurtling around in space as we speak, and if just one hit the Earth, it would eventually turn it into a strange Earth. What that really means? Oof, honestly, I don't know, like we're all living in the upside down or something? A little note about this mysterious strange matter. Some scientists think that it could be the dark matter we see peeping and creeping around the universe. A little food for thought to end this video.
What if our sun hit another star? There's actually a scientific term for this. It's called a stellar collision. It's defined as the coming together of two stars caused by stellar dynamics within a star cluster, or by the orbital decay of a binary star due to stellar mass loss or gravitational radiation. While it's extremely uncommon for a star to collide with another star, this type of event is estimated to occur once every 10,000 years. Scientists know it occurs because they've actually observed it happening. Back in September of 2008, scientists observed a stellar merger in Scorpius. At the time, they had no idea what they had just witnessed. It's believed that any stars in the universe can collide while fusion is still active, but also while they are dead stars, which is when fusion is no longer taking place. The star that is most likely to collide with our sun is Gliese 710, which is 60% as massive as the sun. Though it's estimated that Gliese won't get too close, it will hang out in the Oort cloud, which is the ring of dust, rocks, comets, and debris that circles the furthest edges of our solar system. Even so, Gliese will be 1.4 trillion miles away from us, but will shine brightly in the night sky. Very brightly. Around 3 times as brightly as Mars. Though there's no chance that it will collide with any of the larger objects in our solar system, it very well could shoot comets and debris into our solar system that have the potential to hit Earth. This actually won't be the first time that another star has entered our solar system. It happened once before, and not that long ago either, when early humans were around. 70,000 years ago, a dwarf star entered the Oort cloud, and scientists think that this type of event could have caused mass extinction events on Earth, like the asteroid that is said to have killed the dinosaurs. If a star that far away did enough damage to our planet to permanently eradicate dinosaurs from the face of the Earth, imagine what would happen if a star got close enough to hit our sun. If our sun collided with another star, we definitely wouldn't be around to witness it. It implies that another star would have to get close enough to our sun that both stars would light up the sky, either doubling or significantly increasing the amount of solar energy our planet receives. That would essentially cook our planet. As the invading star got closer to our sun, there would be an epic battle between their competing gravitational forces. They would throw mass and gas in every direction. So if there were any life forms left on Earth at this point, there definitely wouldn't be after this happens. Once the star actually collided with our sun, it would cause a massive explosion, likely big enough to destroy most of the planets in our solar system, and send gravitational waves rippling through the universe. We know this because a gravitational wave was detected on August 25, 2017, and it was believed to have been associated with the merger of two neutron stars in a distant galaxy. This was the first time that an event like this was observed via gravitational radiation. The exact timeline of events of a stellar collision depend on the type of star. Normal stars like our Sun are called main sequence stars. These stars only merge in places where there are many stars in a small area of space, a globular cluster. It's believed that when stars merge in globular clusters, they actually form one star, one very hot, bright star. The subsequent star would be blue, as hot stars are blue. But let's say this is a few hundred million years in the future, and our Sun is a white dwarf. Let's say a white dwarf star collided with our white dwarf Sun. We also know what happens when white dwarf stars collide. It's called a Type 1a supernova, a massive explosion that totally destroys both stars. This would create very bright, luminous energy. Particles like the atomic nuclei of these stars could also be ejected in the explosion. The nuclei will collide with each other and be bombarded by neutrons, which would then convert them into different elements. Interestingly, many of the heavy elements in our universe are formed in this way. But why do stars explode in the first place? Stars are gigantic burning balls of luminous plasma that are held together by their own gravity. A star forms in a nebula from collapsing clouds of interstellar gas and dust. The nebula can go on to form stars the size of our Sun, huge stars 1 to 3 times the mass of our Sun, red giants, and red supergiants. But stars don't live forever. Eventually they reach the end of their lives. Sometimes when a star dies, they explode into a huge supernova, shooting out colossal amounts of energy, light, and matter. The oldest known record of a supernova was from 185 AD. It was seen by Chinese astronomers, who said that it could be seen in the sky for 8 months. The term supernova was first coined in 1930 by Walter Bade and Fritz Zwicky, who used it to describe an explosion they saw in the Andromeda Galaxy. There were only 7 documented supernovas before telescopes were available in the 17th century. One of the most famous was the Crab Nebula. The Crab Nebula was documented by Chinese and Korean astronomers, and it is believed that southwestern Native Americans also saw it because they documented it using rock paintings in New Mexico and Arizona. The Crab Nebula was said to be so bright that astronomers could even see it during the day. Scientists study supernovas because they're extremely instrumental to understanding our universe and how our universe came to be. In fact, it was a supernova that showed scientists that our universe is expanding. Not only that, but supernovas are responsible for distributing matter across the universe. When Moby said we are all made of stars, he wasn't being poetic. The elements found in the core of stars are the same elements we can find on Earth. The stuff of stars gets distributed, it forms new stars, planets, and eventually, hopefully, life. So what causes a supernova? There are 2 ways in which a supernova can happen. The first has to do with binary star systems. Binary star systems consist of 2 stars that orbit around the same point. One of the stars in this orbit is a white dwarf, and it literally sucks the life out of the other star. The white dwarf steals matter from its companion star, but after a while, the white dwarf accumulates too much matter. This causes a nuclear reaction, and the star explodes into, you guessed it, a supernova. The second way a supernova can happen is when a star is about to die. When a star is at the end of its life, there is no more nuclear fuel to burn, so some of its mass flows into its own core. This causes the core to be so heavy it can't handle the gravity, so it collapses. As a result, the collapsing star implodes and becomes a supernova. After a Type 2 supernova, what's left is a really dense object known as a neutron star. They are only a few miles across, but they have as much mass as a star the size of our Sun. A Type 2 supernova can only occur if the star is several times more massive than the Sun. Stars that are extremely massive might not actually explode into a supernova. They could be what creates black holes. So the burning question that I know you're dying to know: will our Sun ever go supernova? Well, not all stars go supernova, and our Sun as it stands right now does not have enough mass to go supernova. It may, however, become a red giant in a few million years, and that will engulf the Earth, and that will cool into a white dwarf. A supernova can be interpreted as the ultimate metaphor for life. Yes, they are gigantic explosions that mark the ending of the life of a star, but they expel particles that go on to create new stars. Every second of the day, a supernova occurs somewhere in our universe, creating new stars, new planetary systems, and eventually, new life forms. Supernovas teach us that even in death, there is life.
What if we traveled to the edge of the universe? Alright, so this video is going to be a very confusing and convoluted one, simply because there really is no definitive answer. The universe is constantly changing, as I mentioned before, and because of this, it's pretty tough to even determine the edge of the universe. Naturally, this makes it even harder to determine what would happen if one were to travel to the edge. But there's much more to it than just that. As we know, time and distance in space doesn't necessarily work the same way it does on Earth. As in, a straight line from A to B on Earth would look very different in space. This is due to the fact that on Earth, or any planet, star, moon, and so on, space-time is curved due to the concentrated collection of mass. Talk about a headache. Now, if you're not a science major and instead just like to lift weights like me, what this pretty much means is that in space, time and distance are measured differently because, as we know on Earth, for example, the shortest distance between 2 points is a straight line. That's just how it works. In space, however, the shortest distance between 2 points depends on the shape of the universe between that distance. We know the entire shape and size of Earth, the universe not so much. And with this in mind, it's actually impossible to even fully understand what would happen if we got to the edge of the universe, if that's even possible to do so in the first place. On top of this, as we know, the universe is constantly changing and evolving, and with that in mind, it's pretty hard to determine a certain distance. However, scientists have been working day in and day out to try and understand or discover more about space, so naturally, let's find out what would happen if you did travel to the edge. Short answer, who knows? Long answer, I couldn't tell ya. Here's the thing. Over the years, we've created tech and equipment that we thought would help us learn and understand space, galaxies, and the universe. And we definitely have. To say over the years there hasn't been significant advancements in space travel and knowledge would be absolutely absurd. However, it seems we may never know everything. As astronomer Virginia Trimble from the University of California explained, I quote, "The universe has always been slightly larger than we could see." And it seems Trimble isn't the only one who feels this way. As Nobel Prize-winning cosmologist John Mather explained, I quote, "Telescopes only observe the observable. You can't see back in time further than the age of the universe, so we are totally limited. We've already seen as far as you could possibly imagine." But just because we can't see the universe going further isn't an indication that it doesn't. From what we understand to be the edge, for lack of a better word, we see what's referred to as the cosmic microwave background radiation, CMB, which is just the leftover glow from the Big Bang. And although at first some thought maybe that was the edge of the universe, in which maybe if we kept going, eventually we would end up back where we first started. That would be the case if the universe was spherical. However, it seems that's likely not the case. The other options would be a saddle-like universe, in which it's bent but not fully spherical, or of course, a flat universe. John Mather went on to explain, I quote, "The universe is flat like an endless sheet of paper. According to this, you could continue infinitely far in any direction and the universe would just be the same, more or less." So I guess that kinda answers our question. There really is no edge, and from what we understand, if you were to keep going even past where the Big Bang occurred, you'd likely just end up finding more space, galaxies, and who knows what else. However, here's the kicker, folks. Although most people do agree that the universe is flat, technically it could be finite, but there's no way to determine that. Trimble explained what you could look for to see whether there's an infinite universe. Nobody quite knows. So does that mean there is an edge or there isn't? Well, as I said before, no one quite knows. It seems the common consensus is that the universe is likely infinite, however, it's possible it's also not. There's a theory that the universe is actually a sphere. However, it's such a large sphere that from as far as we can see, there is no indication of a curvature. In the most simple terms, imagine you have a massive ball, and you're right in the middle, but you can only see about 10% of what's around you. Odds are you wouldn't start to see the curve or spherical shape of the ball, and it would appear flat. That's pretty much what we're dealing with here, and the ball is the universe. It's just so big our brains can't even comprehend it. All in all, if someone were to travel to the edge of the universe, if it even exists, I think it's safe to say they'd die from lack of oxygen, food, water, you know, basic human necessities. And if somehow you were well equipped enough to travel billions of light years away and make it back, well, I guess make it there in the first place, good luck finding your way back. Google Maps doesn't work out in space just yet, and besides, the radiation from the Big Bang thing, yeah, that would probably fry ya. The Earth is always changing. Of course, us living on it, polluting it, or living our best lives, depending on how you look at things, will certainly have their effects. As we know, climate change has been and currently is still happening. Animals are going extinct. We're in the middle of a pandemic. Things are always changing. And if you really think about how significantly things have changed, say in the past 20 years or so, from electric cars to iPhones, social media, all the incredible advancements in science, it's really wild to think about. So imagine how much will happen in a million years. Today on Life's Biggest Questions, we're asking, how will the Earth look in a million years? As I always say, guys, no one is a fortune teller, so we can't say for sure. However, there's this pretty cool thing called science, and it helps everyone understand how things work, including how the Earth is going to potentially shape and be affected over the next million years. Now, it's important to keep in mind there are numerous natural disasters or random occurrences that could happen, which would completely change the course of any simulation previously done. Hurricanes, tsunamis, massive earthquakes, and of course, supervolcanoes are all random natural disasters, if you will, which naturally can happen whenever. And to no surprise, if, for example, the Yellowstone supervolcano were to erupt, you bet your bottom dollar Earth would never look the same. Not at all, whatsoever. Completely different. It's believed this thing going off would wipe out all of humanity and to no surprise would cover most of the Earth in lava or ashes. Wouldn't it be a pretty sight? Well, actually it might be, but we'd all be dead, so we couldn't enjoy it really. This also doesn't consider the fact that an asteroid could potentially come crashing into the Earth, completely changing life as we know it. And it wouldn't need to be an asteroid the size of Earth. As you may or may not know, a lot of the time space rocks do come into our atmosphere. They come at speeds that literally break the rock down. As they reach the Earth's ground, the rock has deteriorated so much, it's often dust. Other times they're able to stay intact, and we've seen asteroids land on Earth before. So it's not so crazy to think in a million years a massive one could come crashing down, which inevitably would have a ripple effect. Literally. Regardless of where the asteroid would hit, if it was big and strong enough to stay intact on the way down, the impact of it hitting the Earth would certainly lead to more trouble. Depending on where it hit, this could potentially be a massive tsunami, volcano, earthquake, and so on. Some pretty scary stuff to think about. We also need to consider things which inevitably come with climate change, such as rising sea levels or extreme heat. Inevitably, the Earth itself would be made up of more water than it already is, assuming the rising temperatures don't allow for anything to freeze. Of course, we could also go to the other route and say, what if there is an ice age, which is also more than likely to happen at some point. At one point, it was believed we'd have an ice age approximately within the next 100,000 years, but it seems climate change is pushing that back. We also need to consider things such as humans' evolution. We have no idea what we're going to be up to. Maybe we'll be extinct. Maybe we'll invent some technology to stop natural disasters and slow the Earth's natural process. As you can see, this question really has an infinite amount of answers. But one thing is for sure, in a million years, the Earth is certainly not going to be the same as it is in the present day. I think we could all agree on that one. Now, how significantly it changes over the years, no one can say for sure. I mean, it seems like a crazy thought, but maybe aliens visit and it becomes an all-out war. Maybe a third world war really does break out between different countries. From a scientific standpoint, you could try to determine what will happen to the Earth and how things will play out, but that's next to impossible given that humans are living here. We clearly have a knack for screwing the pooch, if you will, and who knows what we'll do in the near future that will completely change how the Earth ages, and likely ruin it. The good news is, by that point, we'll all be gone. Like, long gone. So, I mean, may as well just live it up and enjoy our best lives, you know? Let it be someone else's problem, right, guys? I'm just kidding. Do whatever you guys want. To wrap it up, in a million years, the Earth may even cease to exist. Say, if a star explodes and completely blows us up. You guys ever hear of like a supernova? It's pretty crazy. It's also possible we turn up the heat, burn to a crisp, and then have an ice age and start all over again. A million years is a very, very long time away, and as good as science is, well, it's always getting better. So naturally, this answer will probably change by the day. And with that in mind, I'm sure you guys can probably think of a ton of different versions of what the Earth is going to look like a million years from now. Really depends on your imagination, but I'm hoping we have some sort of like Futurama-esque type stuff going on, like little green travel tubes. Those would be really cool. Or even Mr. Zoidberg. whatever noise he does.